in CEMS. Daniel and I are studying for an upcoming test that we have, and we're ready for a coffee break. Luckily, our department gives us free coffee from the break room.
Oh my god, this coffee's terrible. We could do so much of a better job because we're scientists.
Yeah, let's make the most accurate coffee ever so we know it'll taste great.
We've gathered all we need to make the most perfect cup of coffee. To do so, we'll need to pick the right tools to accurately measure liquid volumes. Each of these tools has an uncertainty, and we want to have as small of an uncertainty in each measurement as possible. We'll use a beaker to hold the ingredients as we measure them out and mix them together. Beakers are generally used to hold liquids, but aren't great for measuring accurate volumes.
To measure our coffee volume, we'll use a graduated cylinder since we'll need to measure out 2 cups or 480 milliliters of coffee. This graduated cylinder provides a more accurate measurement of volumes up to 500 milliliters.
With a graduated cylinder, you make the measurement at the meniscus, or the lowest point on the curved surface of the liquid. Make sure that you're looking at the meniscus at eye level. We want 480 milliliters of coffee, so we add enough so that the meniscus lines up with the 480 milliliter mark. When using graduated cylinders, you get to estimate the measurement 1 decimal place past the smallest unit you can measure. So here, we estimate that we have 480.0 milliliters of coffee.
For calculating the uncertainty, check the graduated cylinder and see if it's written on it. Otherwise, check with your teacher. Some teachers use the rule that the uncertainty is half of the smallest unnumbered mark. For us, the uncertainty would be 2.5 milliliters since the smallest unnumbered mark is 5 milliliters.
Next, we'll measure out milk. I prefer oat milk since it's more sustainable. To measure out the milk, we'll need to look at the meniscus again. Here, the meniscus is at the 20 milliliter mark, and like the graduated cylinder, we can estimate 1 digit past the smallest marking, so we have 20.0 milliliters of milk. To dispense the milk, just press this button. Last, we'll add concentrated syrup to sweeten our perfect coffee. We have special, super concentrated syrup, so we only need a small amount of it, and micropipettes are best for accurately measuring very small amounts of liquid. To use a micropipette, make sure you have the right size pipette tip and attach it to the micropipette.
We want 800 microliters of syrup, so we need to set the volume of the micropipette by twisting the plunger to the right number.
To dispense the syrup, push down the plunger again to the first stop or click, wait 1 second, and then push it all the way to the bottom.
The uncertainty of the micropipette is usually written on it, so here we have 800 microliters of syrup with an uncertainty of 10 microliters.
Now that we've added all of our ingredients, let's stir our perfect coffee and mix it all together. We've made about 500 milliliters of coffee. We can see that it's close to that marking on the beaker, but the uncertainty of this measurement is still quite large because the smallest unnumbered markings are very far apart from each other. The beaker's smallest measurable unit is 50 milliliters, so the uncertainty is 25 milliliters. We've made somewhere between 475 and 525 milliliters of coffee.
Now that we've made our perfect cup of coffee, cheers!